Now we will continue our discussion and discuss about the graphical representation of motion. There are two types of graph: distance time graph and velocity time graph. Let's see the distance time graph. Distance time graph, that is change as it written here, change in the position of an object with time can be represented by distance time graph. Distance on the y-axis and time on the x-axis. We know the water axis and how we will do. So this is the graph of the velocity distance time graph when velocity is uniform or velocity is constant. Let's give an idea how it works. Suppose this is our axis. The x-axis represents time, y-axis represents distance. Suppose at a time at t is equals to 0, object is at rest. This is one is called origin. At t is equals to 20 second, object is at object has traveled 10 meter. That is object is here. T is equal to 14. It has traveled another 10 meter. That is at here. So when we join this line, what we are getting? A straight line. So this is the nature of graph when velocity is uniform. Now discuss if the velocity was not uniform. That is, if in t is equals to 0, it is traveling 0 kilometer. Obviously it is at origin at rest. For t 2 seconds it is traveling 1 meter. For another 2 seconds it is traveling 4 meter. Then next 6 seconds it is traveling 9 meters. So this type of graph how we will plot. Suppose this is distance and this is time. So this is 2, 4, 6. So when velocity is not uniform, this at 2 it is traveling 1, suppose at 4 it is traveling 3, and at 6 it is traveling 5. So you can see here when we join these points, what we are getting a non-linear graph. So this is the difference between when velocity is uniform and velocity is non-uniform. When velocity is uniform, we are getting a graph, a linear velocity graph, and velocity is non-uniform, what we are getting a non-linear graph. So this is about the distance time graph. Always remember, distance is distance is directly proportional to time. Whenever you see this symbol, this is called proportional symbol. So whenever one quantity is proportional to another, the graph between them is always a straight line. Now we will discuss the velocity time graph. So velocity time graph, if we take under the uniform velocity time graph under the uniform velocity, it will be a line parallel to the axis, parallel to the what? Time axis. See here in this figure you can clearly see it is a velocity time graph in the time axis. This is due to since velocity is 40 km all the time, at t is equals to 2, t is equals to 4, t is equals to 6, velocity is always what? 40 km per hour. So whatever you are getting, you are plotting points like this only. So when we join this point, you are getting a straight line parallel to the time axis. So if we join t is equals to 2 here and t is equals to 4, what we are getting? A rectangle. An area of this rectangle gives us the distance traveled between t is equals to 2 to t is equals to 4. So we will discuss now. Now assume, can we use these graphs to find the distance? Yes, we can find. So let's see. Let's use the distance time graph to find the velocity. How we will do? Let's check. If let's check here, it's t is equals to 2, a velocity is at a, t is equals to 40, velocity is at a, take it distance traveled is s1, at t is equals to 60, it is at b, that distance traveled is s2. So velocity will be s2 minus s1 by t2 minus t1. s2 minus s1, that is distance traveled at during time 2 minus distance traveled during time 1, and that is change in time. s2 minus s1 by t2 minus t1, we can easily calculate that distance using this graph. Now, when velocity is changing at uniform rate or body is under uniform acceleration, this is the graph. This is the graph if a body is in uniform acceleration. What is uniform acceleration? If a body is changing its velocity equally in equal interval of time, that is, in first hour, in 1 hour it is changing 2 km per hour, in second hour it is running with 4 km per hour, its third hour it is running with 6 km per hour. Now see, the change is constant, change is of 2 km. So under this type of motion is called accelerated motion, uniform accelerated motion. So if a body is in uniform accelerated motion, this is how you will represent the graph. This is how you will represent the graph of it. If a body is a non-uniform and non-accelerated motion, this is the graph, that is, it is not shown. So that's it for this video. We will discuss the circular motion in the next one.